Today we will try to discuss some more questions, good questions that will be very important for NEET exam. Any problem in today and yesterday's lecture? Any question? Can we discuss any problem? Any problem in yesterday's question? Any of the question which I think I have given homework? Any problem? Okay, nice, no problem. Good. Try more question. These were just question of yesterday which we have discussed. Same question I mentioned here. Same question which we have discussed yesterday. Now, up to 10 questions we have discussed yesterday. Okay. Today we will start our discussion from 11th question. Now, let us try this. I give you 10 seconds. You should try this question. Try this question once. Try this question once. Oh, I think try this question once. Try this question. Take 10-second time and try this question. What it is telling? Okay, see what it is telling, that we are having 4 charges plus q and combination of charges is shown here. You can see, and it is telling that side of a square is 2L, and it is telling that for this electric potential at A, at this point, electric potential will be what? This point, it is between plus q and plus q. What will be what? Any answer? Any guessing? Okay, nobody. Let us go through the question. How we can solve it? Let us see. Any answer? Any answer? Okay, no problem. We can see here. We will see that this will be L. This will be L. We can write as by superposition that the potential will be, electric potential will be, what it will be? V is equal to summation of all the VIs, that is V1 plus V2 plus V3 plus V4. Add up all the potential. You can find, you will add, you will get it. This distance is L. This is L. You can write potential here. And for this minus Q, you know this distance, what it will be? This is L. This is 2L. This is L. This will be root under 5 L. And same from here also, root under 5L, like this. So similarly, you can write for both, for all the charges. You can try. Please write, you can try, or I should solve it. I think it's just a waste of time. You can try, please tell. Oh, good. Yes. Like this, you have to proceed, and you will get the answer like this. For this charges, what I have taken? For this charges, I have taken distance L. You can see L, and multiplied by 2, because for this charge and this charge same electric potential, so multiplied by 2. And for this also multiplied by 2, because for this and this electric potential will be same and it will be negative. That's why I have taken negative and multiplied by 2. You will solve it and you will get the answer. Okay, you should try. Now let us move further. I give you 10-second time to think upon it. Think. Option D. Okay, so fast. Good, so fast. Okay, nice. It is telling that, you can see here, it is telling that. Okay. You know, it is telling that charges are present, capital Q charges are present here and here, and it's telling that in what direction electric will be present at the fourth corner here. You can see for this charge plus Q, electric will be in this direction, and for this charge, electric will be in this direction. Let us suppose E, and it will be E, and we know that for these two vector, when we add them together by parallelogram law, we will get resultant in this direction. Sorry, I have drawn like this. It is straight line. Straight line. We can draw like this. It will be a straight line like this. Okay, and it will be E root 2. Now, for this charge, it will be along this direction. We know, and it will be how much? We know this distance. It will be in this direction, but this will be more than this. So net electric field will be in along this direction, that is OB. You can find it by finding the distance from here. So net direction will be OB. Any problem? Should I solve and show you, or you can proceed? Any problem? Okay. Solve, sir. Okay. I will solve. Okay, I'm solving. See, let us suppose this distance is A. We can say that, wait once. We can say like this. Here electric field is E, here it is E. We can say that, let us suppose E will be K Q by A square, this, and net electric field will be E root 2. We can say like this, K Q by A square into root 2. This will be along OB direction, OB. Now we find electric field due to minus Q. What it will be? It will be E is equal to K Q by what we will write distance? This distance will be A root 2. We can write like this, A root 2 whole square, and it will be along OE. We can say that when we will solve it, we will get KQ by, from here we will get 2A square along OE. If you will look after these values, this value and this value, now we can write like this. Here you can see this and this, which is greater. You can see this one is greater than this. So net electric field will be along OB direction, because they are along a straight line. You can see here they are along a straight line. It is this direction and this is in this direction, and it is greater. So net electric field will be in this direction. And what will be the net electric field? It will be this KQ by A square minus root 2 minus 1 by 2 along OB. Any problem? You can solve it and you will get the answer. Sir, how E root? Okay. This one. Okay. Let me tell you. You know, whenever there is a two vector like this, one is A and another is A, and they are at 90 degree, by parallelogram law, when we will apply the parallelogram law, that is A square plus 2AB cos theta, AB cos 90. You know, this will be 0, cos 90 0. Root under A square. What you will get? 2A square, and it will result to A root 2. So directly we remember, whenever there is a two vector 90 degree, their resultant will be A root 2 always. For two equal vectors at 90 degree. Here you will see, here you can see there are two vectors You can see here there are two vectors. See, one vector this side, one vector this side, and they are 90 degree. So we can write here the resultant will be e root 2. Don't write top corner of the screen. Okay, sir. Okay, I will try. Any problem? Anyone has any problem? Okay, now let us move further. Anyone has any problem, any concept, any step? You should remember this type of question. Okay, shall I move forward? Okay, now let us move forward. Try this question. Try this question. I'll give you 10-second time to try this question. This type of question usually come in your exam. You should try this question. I'm giving you 10 seconds. Read the question once. What it is given? It is given that you can see there are two charges, E and 3E. You can see one is E and another charge is 3E, and they are separated by distance R. And it is telling that the distance of a point from electric field, where electric field will be 0. You have to find that point. Always remember, to find the point where electric field is 0, what we will think? We always think that since the two charges are of same nature, either they can be positive or they can be negative, but it is not given, so we will consider both as positive nature. Okay, now, but we know this is greater in magnitude 3 times of this one. So when we have to find the where the electric field intensity will be 0, we have to see, we will see that there are three possibilities. First here, second possibility here, and third possibility is here. We should check. Now, in third reason here, it is not possible to have E0, because we know that to have E0, we know that since we know that electric field is inversely proportional to R square by formula. We know that to have electric field balance, we have to make greater distance with greater charge. If this one is having more charge, then we have to move far distance from this charge and closer to this charge. Then only we can balance electric field intensity by common sense. So we will think it can be either this side closer to E, or it can be this side, so that it will be closer to E. So they do two possibilities. It can be here or it can be here. So what we consider, let us consider this is X here. This point be X. Okay. So from 3E, this will be at a distance of R plus X. Now, at this point, we have to write electric field intensity for E. What it will be? K E by X square is equal to, for this point, this charge, we can write K3E. We know electric field is equal to K Q by R square. We will write K, this is Q by R square. Distance is R plus X whole square. We should solve both sides, and after solving, we will get the value of X, and X will be the answer. Remember one thing, if we get X value as positive, then we should think that our assumption was right, that is along this side. If we get negative value of X, then it means that our assumption was wrong and the point was along opposite side. So we should think, if we get both the values positive and negative and both are real, then it means that we will get 2 points, one this side and one this side. So we have to solve this. It will come as a quadratic equation and we will get the answer. Any problem till now? You can ask any problem till now. Any problem till now? Any problem, anyone? You can solve it. Any problem till now? Anyone, any problem? This type of question usually come in your exam. Similar type of question comes for electric potential also. Similar type of question comes for electric potential also. Similar type of question. Okay, electric potential also. Let me see. Sir, how do you take distance from E? Not. From E not. Okay. Let me tell you. What? Not from 3. Okay. It is not having any condition. We can take distance from 3E also. Let me show you after taking the distance from 3. Let me show you. If suppose I take distance from like this, there is E, it is 3E, and suppose I take distance point here, and this point is, let us suppose x. Then this will be r minus x. Okay, and similarly you should pursue like this only, but you should remember we have taken this distance from 3. So if we not get any answer from 3, then what we will do? We will subtract r minus x, then we will compare the answer from E. Okay, what we will write? We will write k 3e by x square is equal to k e by r minus x square, and we will solve it accordingly. We have assumed here also this point can be here also. Okay, if we will, after solving this, we will get the answer, and according to that we will decide it is point is here or both sides. Got it? Or still having any problem? Got it? Or still? Please don't hesitate. Okay. Other people's any problem? Please interact. Any problem? Today is very important session. We are discussing direct questions of your exam and also some of the important question for your exam. And remember, this question usually come in your exam, and also it comes for electric potential also. Electric potential. Same concept we apply, only we apply the formula of electric potential is in place of electric field. Okay. So let us move further then to next question. So I give you 10-second time. You try this question. All of you try this question. I give you 10-second time. All of you try this question once. Take 10-second time and try this question. Option A. So firstly, good. Other people try this question. Okay. No worry, we are discussing here. Question here only. No. Let us discuss. It is given that E is like this. It is in along X, Y, and Z. It is oblique electric field. Now, it is given that calculate the electric flux. We have to calculate the electric flux through a surface area lying XY plane. Okay, it is given a surface area along XY plane. That means one is along YZ and Y, and other side is along Z axis, and this is along YZ plane. That means perpendicular to it, it will be X axis. We know. Now, Also we know that area vector of this YZ plane will be how much? It is given 10 unit. That means we can say 10, and it will be perpendicular to the plane. That means the area vector will be along the x-axis. So we can write in vector form like this, 10 I cap. Now we got the area vector. Now we can see, we know flux is equal to E dot A dot product. So for E is 10 I cap, doing dot product, you know all. Okay, so dot with 10 I and you will get the answer. Okay, any problem to anyone? Any problem to anyone? You can discuss with me. I give you 10-second time. You try this question. Think, how will you proceed with this question? Think. Everyone, all of you should try. Take 10-second time and try this. Take 10-second time. Option A. Option A. Okay. 0. Okay, let me see. Other people also try this question. It is telling that 3 charges are present here, and here, and it is telling that it is also telling that 2A that way. And also you know, you usually know that by if it is midpoint, it will be A like this, A, since it is a midpoint. Okay. Now it is telling that what will be the work done if to bring a charge capital Q from D to E. Suppose we are bringing this charge from here to here. So whenever it is telling that we have to find the work done, what you will do? You will find the potential energy. You will find the potential energy at final point, and you will find the potential energy at D. And if you find this, only subtract them, find the value of this, you will get the work done, change in energy. Or there are few methods more, but this is the best method. So you will see that at this point potential energy will be same as it will be at E point, because at D point all the distances from B and C and A are same as compared with E point, because at E point AE and CE both are equal, and also BE is same as AD. So at E point also potential will be same as D point. So either we will say that DE, the line DE, this line DE, this line, either we can say that the line DE is equipotential surface. So work done on equipotential surface is equal to 0 by this way. Or we can say like this, work done is equal to UD minus UE, and we have seen that both are equal, so it will be 0. By both way we can say. Okay, so answer will be 0. Now, any problem here? Anyone, any problem? Okay, let us move forward. Please interact. If you will interact, session will be very good. Okay. Try this question. I think this will be just a revision of a concept which we have learned in our class. Take 10-second time and try, all of you. Try. Take 10-second time and try, all of you. All of you try, take 10-second time. Okay, okay. No worry. We are discussing. It is given that any answer, anyone, any got any answer? Anyone, any got any answer? Anyone? So, no worry. We will discuss it. We will discuss it. It is given that v is equal to minus x square v. Like that, it is given here. Okay, 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 okay. Then they got answer C, option C. Okay, let me check it. So, to find E, we know that to find E, we have to find first EX. EX means minus dV by dx, like this. Okay, and then we multiply by I cap. So, differentiating this with respect to x, what we will get? If we will differentiate it, what we will get? Minus sign outside the bracket. Differentiate this, what we will get? Minus 2x minus 2xy minus, and here yz is constant. Yz is constant. Okay, now x, yeah, we can write like this: z cube plus 0 and multiply this with I cap. Now we will check this option. Any option like this, we will check, and minus sign inside. We will check that any option like this, we are getting here. You can see first term is matching here. You can see here first term is matching. So no need to move further. We are getting the first term because others are different. You can see. So option we will see, and similarly you can check for EY also and UZ also. You will get the answer. Okay. Anyone, any problem? Any problem? Anyone? Okay. Okay. Please interact. The session will be very much useful for you if you interact. Okay. Okay. Now, let us move forward. I give you 5-second time. Please write your answer. What will be the answer for this question? Just a conceptual question, theoretical base. You can try this question. Try once. Any answer? Anyone? Any answer? Any answer? Anyone? Okay. Okay. Let us see. You can see that. Okay. Okay. To answer K. Good. To answer K. Okay. Let us see. It is telling that when we are looking after the electric field, we know electric field is represented by density of electric field lines. Density of field lines. To find the density of field lines, we draw equal area along both sides. Equal area. You will see that in the same equal area, more denser field is observed here with respect to this point. So we will say that EY is greater than EX is greater than EY. Answer A will be correct. Okay, good. This question, try all of you. I think this is just a revision. In our previous class, we have done like this question, I think. Anyone? Try once. Try. Okay. Last question. Sir, can you explain last question? Okay, sure. I'm explaining the last question. This question. Okay. Let me explain this question once. What it is telling that, we have learned in our theory that whenever there are field lines which is present anywhere, how do we not this last. This two. Oh, इससे पहले जो किया. Okay, okay, okay. This one, this one, this one, this one question. Adiba, this question. Okay. Okay, 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 okay. Let me tell you. Let me solve it. Let me. What is the formula? We have discussed this in our class and we have taken a more difficult question using this formula. Now, what is the formula? Formula is that to find Ex, electric field, what we do? We know dV is equal to minus E dot dr. This is a formula. From here, we came to know that E is equal to minus dV by dr, like this. So, to find the electric field, what we know? We know that this dr has three components along x, along y, and along z. So, we find three components of electric field like this. First component Ex, it will be minus dV by dx. When we are differentiating with respect to x, then y and z will be constant, like this. Similarly, when we are finding Ey, then dV by dy and x and z will be constant. Similarly for Ez also. Now, what we did? We have to differentiate this. V, what is V? V is given, this V is given here, you can see, it is given x square y minus xz cube plus 4 by dx. Differentiate this, but assume that y and z are constant. So, if you know differentiation, it is just a question of differentiation. So, for differentiating this, there is a minus sign outside also. So, differentiating this, you will see that y is constant, it will be constant, y will be considered as constant. So, considering y as constant, this one as constant, it will get outside. What will happen? Minus and above, outside, y outside, and we will get differentiation of x square. It will be minus of 2x square. Minus sign is present outside here, you can see. Again, next term, it is xz cube, and we have assumed z as constant. So, z will be outside, and x, differentiation of x is 1 plus constant differentiation will be 0. What we get? When we put this negative sign inside the bracket, we will get this minus sign will go inside, make it positive, and positive. We will get 2x square y plus z cube. We got this, and this is Ex, x component of electric field. That means I cap multiply. We will check this option matching. So match this answer. Similarly, we will find Ey, and we will get the same value like this. Ez also, we will get this only. Any problem? Or I should do all? Okay. Okay. Now, I think previous question, someone was answering. This question. Try this question once. Try this question. Everyone try this question. Try this question. What will be the answer? Try this. Oh. It is easy. Oh. Very good. Okay. Now. Let us see. It is telling that a charge Q, it is telling that a charge is placed at the center of cube and it is telling that what will be the flux through one of the faces. Remember, if it is asking what will be the electric flux through cube, then it will be d5 is equal to q enclosed, that is q by epsilon naught, and it will come to be phi as phi total for cube. It will be charge enclosed by epsilon. This will be answer for cube. That means for 6 faces. For 6 faces, this flux will coming through this faces, this face, this face, this face. Similarly, 6 faces. So, but in the question, it is telling one of the faces. So, for one face, it will be 1/6 of q by epsilon naught, and this will the answer. Okay. Any problem? Okay. Okay, I think this is just we have done this type of question yesterday lecture. Please take 5-second time and answer this question. Only 5-second time. Take 5-second time and answer this question. Try in 5 seconds. Any answer? Any answer? Any answer came? Try this question. Okay. Okay. Let us see. It is telling that, question is telling that a charge Q is placed at the center of an open end of a cylindrical vessel. There is one cylindrical vessel like this. There is one cylindrical vessel like this. And it is telling that a charge Q is placed. A charge Q is placed at the center of here. Okay. And it is telling that what will be the electric flux through the surface of the vessel. Okay, through this surface. The last question is this question Adiba, this question Adiba, this question you was talking about. Okay. I try my best to explain this once more. Look, we have studied in Gauss law in our lecture. Whoever attended this, we have to study Gauss law is equal to charge enclosed by epsilon naught. This is a Gauss law. So it is telling that, let us assume that this cube is a Gaussian surface. If it is a Gaussian surface, we will write integration of the d5 will be flux phi is equal to charge enclosed. It is telling that charge q is inside the center of the cube. That means inside the cube it is q charge by constant epsilon naught. This is the flux through the cube. This is the flux through cube. Cube means 6 faces. 1, 2, 3, 4, 5, and 6 faces. 6 faces. So this is q by epsilon naught for 6 faces of cube. 6 faces of cube. But question is telling for one face. For one face, so we know you will apply the unitary method. For 6 faces, this one flux. So for one faces, divided by 1/6, and factor will be divided here, and you will get this much of flux through one surface, one face. If suppose in exam it is telling that what will be the flux through 2 faces, what we will do? We will do like this. Since for 6 faces it is q by epsilon naught, so for 2 faces it will be q by 6 epsilon naught into 2 for 2 faces, like this. Any problem? Clear? Not clear? Please reply. Please reply. Any problem till now? Clear? Not clear? Okay. You can find by this way for any phase, number of phases which will ask your exam. Any problem? Adiba clear? Reply. Let us move forward. Any problem you can reply. Okay. Let us see this. Let us see this. And remember the previous which I am discussing here. Almost similar concept I have discussed in my lecture, and also similar type of question I have discussed in my class also. Okay. So, and if the question is remains, no worry. At the end of the session, you can ask same question. You write only the number of that question, and when we will end the session, you can ask that question at the end of the session. Don't get worried. Okay. Now, it is telling that center of the open cylinder. Now, we have discussed this type of question. So, what we will do? We will complete the cylinder like this. We will draw the complete cylinder like this and make it a closed surface. Now, it will be a cylinder, total cylinder. What we have did? Yes. So, what we did? We completed it. And we know that it will be d phi by q by epsilon naught for whole cylinder. This one which we have drawn like this for whole. But in our question, it is given only for this one, red one, for red one. So phi is equal to q by epsilon naught for whole closed cylinder, for whole closed cylinder which we have drawn. But question is asking for this one, only red one, half cylinder. So it new find us for given half cylinder, it will be q by epsilon naught, and one factor will be divided 1 by 2, and this will be the answer. Any problem? Anyone? Any problem to anyone? Okay, let us see. Okay. All of you interact. If you face any problem, you can ask. I give you 10-second time. You should try this question. These are good questions. You can try. You will try. You should try. Try this question. Try this question. Take 10-second time and try this question. Anyone? Any answer? Any answer came? Option B. Okay. Let us see. Option B coming. Let us see. 4. What does it mean? Okay. Getting confused. Diva 4. You should write ABCD like this. Okay. Nobody. Let us discuss. It is telling that hemispherical surface, and it is having R, is placed in a uniform electric field E. What will be the flux to the curved surface here for this curved surface? So I will give you one trick here. And you will apply this trick, and it will be very much useful to you. Okay? For this question, I will give you one trick. Now, if flux is asking for any of the surface, what you have to find? For the surface, it is asking for the curved surface, for this surface. What you will do? You just try to see, if you are present here, what will you see the image of this curved surface? What you will see? You will see that this curved surface will appear you like this, a disc. When you will see the back side of a bowl, what you see? You see it appears like a disc. or a circle. And we know if it appears like a circle, any figure, draw it, find the area. Area will be pi r square. And we know flux will be electric field into area. That means E into pi r square. So I think answer was correct. B. If suppose electric field is here like this, and it is telling, if it is given that suppose like this, a cylinder is placed like this, having radius r. Sir, area is perpendicular to electric field. Area is perpendicular to electric field. Area is perpendicular to electric field. You can see here, when we see that this is the curved surface here, this is the curved surface. When you will look at this, for any, if we take any small area here like this, if we take any small area like this, let us suppose we are taking this small area here, area is always perpendicular to surface, and area will be here dA. You can see it is dA. Area is always perpendicular to the surface, so area will be along this side dA, and electric field is also along this side E. So they are not perpendicular, they are parallel to each other, and we know E into A into cos 0. Okay, what comment are coming? Okay, so for this triangle, okay, for this I was discussing here, for this cylinder, if what will be the flux for this, and if suppose one cylinder is like this, suppose E is here, okay, you have to find the electric flux through this. 0. Remember one thing, before giving the answer of any question, please think once, twice, then answer. Now, I have given you one trick. What? You see, when we are talking about this cylinder, what you will see? You imagine that you are seeing this cylinder from this side you are seeing. What you will see? You will see that it will appear like a disc. Only this you will see. What you will see? You will see this, and if suppose it is having area r, that means radius r, then flux will be electric field into pi r square for this type of cylinder. And if the cylinder is like this, vertical cylinder, then what we will do? For this, we will see like this. From here, it will appear like a rod or rectangle. Similarly, we will do for this. I think one question is there in our question set. We will discuss there for this. Any problem for this cylinder? Any problem? Anyone? Adiba, you got it? Anyone? Any problem? Please tell anyone any problem. Please discuss anyone any problem. Okay, Adiba is telling that for the she is telling that for horizontal cylinder flux is equal to 0. Remember, Adiba, remember, I tell you one thing. No worry, no problem. I tell you one thing. If suppose you are telling it, if suppose it is you are tell that find electric flux, find electric flux through curved surface, through curved surface of cylinder 1. This is cylinder 1. You have to find the electric flux through the curved surface. So curved surface is this one. This one, it is a curved surface. So for this, if you will take the area here, it will be perpendicular to it, and this area will be perpendicular to electric field, and for the curved surface you will get flux is equal to 0, because for the curved surface area will be perpendicular to electric field and it will be 0, but for this it will not be 0, because it will be parallel to electric field. So there will be some value which we have calculated here. Okay, any problem? You got it? Okay, any problem? Try this. I give you 5-second time. You try this. All of you write the answer. All of you try this. All of you try this. All of you try this. Answer came. Nande, answer B. Adiba also, you also try. All of you try. Okay. Let us see. Flux entering is negative, flux leaving is positive. They cancel each other. Okay, you are telling that flux is negative, flux leaving is positive, so they will cancel each other and it will be negative. I think you are talking about the previous question. For this, okay, no, don't get confused. I tell you once more. Okay. Let flux, no. Actually, what I was telling that, you can see here what I was telling that. You should see. I tell you in very short. I will explain you very short. Please look after. I was telling that if there is one electric field, suppose if there is an electric field present like this, and there is one cylinder here like this. Okay. If suppose we have to find the flux through this cylinder, what we do, we take area here. Suppose this area will be this along this side, and this area will be along this side like this. Okay, got it? For this along this side, along this. Remember, I am telling that I have to find the electric flux. Okay. Sir, for first circuit, actually I am talking about that only. Okay, I understood. I got it. I got you. Actually, see, I got your confusion. For this phase, we will get electric flux along this side, because electric flux, it is present. I am talking in my question, I was telling that for this phase only. If we are talking about for the total cylinder, it can be 0, because we will calculate, it will be positive here, it will be negative here. That is correct. For this it will be 0, here is 0. It is correct. But I was telling for this phase only. For total phase it will be 0, but I was telling for this phase only. Okay. If it is given for a whole cylinder, flux will be 0, because this positive will get cancelled with negative. That is correct. Okay. Adiba, are you getting? Adiba, getting? Okay. Now try this. You was correct in the last question also. You was thinking for a whole cylinder, but I was telling for only one side. Okay, 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 okay. And now you actually in last question you was telling for a whole cylinder, but I was discussing for one of the face of that cylinder. So you was also correct, and I was also correct. Okay. Now let us try this question. This question, it is telling that. Okay, okay, okay. Now, first of all, polarity. We will see that both will be positive, positive, both will be positive. And when we are talking about strength, we will find that the strength of Q1 will be more than Q2. That will be answer will be B. Okay. Now let's move further. This question, try this, and I think this question we have discussed in our previous class also. This is just a repetition of that question. You can try this, but same question we have discussed. Same question. You can try this. Okay, you will try this question. What it is telling that electric field is. Wait. One problem occurred. Wait. Power shortage is occurring. Wait, 2 minute time. Give me 2 minutes. Give. In this question, what you are seeing that in this question is telling that electric field is along x direction. The work done on moving a charge of 0.2 coulomb, it is given 0.2 coulomb along a distance of 2 meter along the line making 60 degree with the x-axis. From here 60 degree here, okay, and 60 degree here, and from here we have to move 2 meter here, and is telling that the work done is equal to 4 joule. What we have to do? Electric field is along this direction. Okay. How we will do? You know, dV is equal to minus E dot dr. That means E dr cos theta. Okay. You can find the dV. You can find the dV. What will be the dV? dV will be integration of minus E. Electric field is given like this. What it is given? It is given. Okay, you have to find electric. Okay, E into dr. Distance is given as 2 meter. 2 into cosine of angle between them, cos 60 degree. This will be equal to potential difference V is equal to minus of 2E cos 60. I think it is 1/2. Like this. Now it is given that also given that work done is 4 joule, and we know that V is equal to U by Q. Okay, we know. Now we know that V is equal to U by Q. U given 4 joule and Q is given as minus 2 coulomb, 0.2. That means 40. We will cut here. It will get 20. Put here 20. Then you will get ES magnitude as 20 volt per meter, 20 volt per meter or Newton per coulomb. Anyone, any problem? Anyone, any problem? Please respond. Anyone having any problem? Okay. Okay, nice, very nice. Okay, she's telling, can we use P sine theta? Okay, think she's telling, Diba is telling that, can we use this formula P sine theta? P sine theta or cos theta? PE sine theta. Okay, okay, let me discuss. P sine theta. Remember one thing. U is equal to minus P dot E. This is a formula of electric potential energy for dipole. Okay. Here, there is not any dipole. The single charge of minus a single charge of 0.2 coulomb. No dipole. So we can't use this formula. We have to proceed like this only. Okay. Any problem till now? Okay. Now, let us move forward. Try this question. I give you 10-second time to try. Try this. All of you try this. All of you try this. So, last question. Okay. Any problem? Adiba, you can ask. Any problem? No worry, you can ask. Any problem? You can ask any problem if you are facing. You can ask. Is it okay? Is it okay now? Can we move further? Okay, Adiba? So, any answer for this question? Try this. Any answer for this question? Any answer? It is telling that charges plus Q and minus Q are placed at a point of A here and B. At 2 points, it is placed here at A and one at B. Here it is placed as plus Q and here it is placed as minus Q. And they are L distance apart. And C is midpoint between A and B. It is telling. So we can write it like this: L here and L here. Okay. What will be the work done in moving the charge plus Q along CRD? If we are moving one charge plus Q from here to here like this, what will be the work done? So to find the work done, what we will do? We will find the energy at D and we will find the energy at C, at initial point and at final point, and then we will take the difference of the both. We will get the answer. Okay. So what we will do? We will do like this. We will find UC, potential energy at C. We know for this point it will be minus K, capital minus K Q by L, and by L here for this two system, and for this it will be minus K Q by L. Okay. And I think it will be a positive. So total will be 0. At point D, it will be minus of K between this A and D, K capital Q here into small q by distance will be L. This is radius, so L here, L. We will write that like this: 3L plus at this point electric potential for between this will be for B and D it will be electric potential will be minus minus will get plus, so we will write K Q by L. You will find anyone has any problem till now. You can find here. It will be 3L, and you will get the answer from here. It will be, I think, it will coming like this 3L, and you can write like this. I think you will get here 3, and you will get yes. You will get answer. You will get here from here answer. Any problem till now? We will get UC and UD. You will subtract both of them. Since UC is 0, so your UD will be the answer. Any problem? You will solve here, subtract both this term, and you will get the answer. Any problem till now? Anyone? Any problem? Or I should solve the question and tell. Anyone, any problem? Because there are lots of questions. I don't want to waste time in solving the answer and getting the answer like this. Anyone, any problem till now? You can solve it. You can solve it. No answer. Let it be solved. No answer. No answer. Why? It will be 3L. You can write like this. Minus KQQ plus it will be 3KQQ by L, and you will get minus 2KQQ by 3L like this. Okay. Like this. Now we have to, you will see that. Okay. Now some are thinking we are not getting the answer. Now it is minus 2 by 3L. Now, value of K we know, 1 by 4 pi epsilon naught into capital Q into small q. You will solve this and you will get the answer. Any problem? Any problem till now? It will be a positive sign. It may be positive sign because here we will get this. We will subtract here. We will get positive sign because this will be UC minus UD. When we will do here, it will be mod of UC minus UD, and we will get positive sign here, and we will get the answer as A. Any problem? Any problem? Any problem? Anyone? Okay. Clear. You can ask anything because I don't want to waste the question timing in just solving and getting the answer. Okay, because we are having lots of questions to do, to practice, and from tomorrow we are going to start one of the important topic, that will be capacitor, and we will wrap it in 2-3 lectures, and it will be very good, very much beneficial for you to understand the current electricity. It will help a lot. So try this question. Only 5 seconds. Try this question. Class timing, you should discuss this with Ganesh sir. Ganesh sir will guide you regarding the classes. Okay. So we will focus on this question. Write the answer. What will be the answer? Try. I will giving you 5 seconds. Please answer the question. Try, all of you. Try. Now let us see. It is telling that a charge plus Q is placed at origin. Here charge plus Q is present here. Now work done in taking another charge plus Q from point A to point B here. Okay, you can see from here the distance is same like this, so potential will be same, A and B, so it is equipotential, so work done will be 0. No worry, no problem, we can say direct 0. Okay, Same distance, we know, same distance here also, same distance here also, potential will be same, so work done will be 0. Okay, because potential is not changing, that means potential is not changing, that is U is not changing, that means no work is done, not changing, that is work done is 0. Okay, try this question. Try this question. This is same type of question, and I think I will not answer this question. You try. This will be answer. This will be your homework. You can try this question. Take a screenshot of it. Okay. Try this. Try this question. All of you try this question. Okay. Okay. Try this question. Try this question. All of you try this question. Try this question. Now, I'm telling you one thing. It is telling that charge by mass ratio. It is called as E by M ratio. It is not ration, it is ratio. E by M ratio. Remember, the particle having option A. Okay, let me see. Which particle has, it is telling that same velocity to a field, which particle has E by M ratio greater. Remember one thing, the particle which will have more E by M ratio, more E by M ratio, that means more deflection by electric field, that will deflect more by the effect of electric field. You will see both are thrown at a same point parallel to electric field like this, perpendicular to electric field in this direction from plus to minus. You can see this one has shows more deflection. You can see this one. So it means this will have E by M ratio more, maximum E by M ratio, because more deflection is shown by C. So more deflection will be shown by C. Okay. We can calculate different things also, but it is mostly for JEE people. We calculate what will be the acceleration, what will be the velocity, like that. But for it is only necessary for JEE people. For you all, we note only this type of concept. Okay. Okay. So try this question once. Try this question once, all of you. I think this is your homework. Try this question. All of you try this question. Only all the values are given. No other concept. We have done question like this. Only values are given. Electric field is given and all radius are given. Okay. You have to find the electric flux through a cylinder. Okay. And I think you will try. All of you try. This will be your homework. Okay. Note this question. If you will face problem, you will ask. Say only the question number. I will go to that question and answer you the answer. Adiba, for tomorrow class, Adiba, for tomorrow class, I am telling that usually a physics class occurs at 9 p.m. Monday to Saturday. But for more details, you should ask with Ganesh sir or Rizee team. They will help you. Okay. So this will be your homework. Let's move to next question. I think this is also similar type of question we have discussed earlier. So let us find this. Try this. I give you 10-second time. All of you try this question once. Try this question once. All of you try this question once. Try this question once. All of you try this question. So see. So firstly, okay. Okay. Let us see how it is solved. It is telling that electric charges plus Q and minus Q are placed at the corner of equilateral triangle. It is given like this. Equilateral triangle is here present like this. Plus Q minus Q or plus Q and here 2Q. We can write minus 2Q like this. Q and Q. This minus Q and plus Q, they will make one dipole and this will make another dipole. So we will get two dipole, and we know dipole moment is from minus Q to plus Q. So one dipole moment will be along this direction like this. One dipole moment will be along this direction, and we know it will be P is equal to QD, and side is given L. So it will be Q into L. Angle is 60 degree, and you can find the resultant. Okay. And answer I think you will see only. Okay. Now. Okay. Yes. Good, Adiba. Try this question. I give you 5 seconds. Try this question. Try this question. Try this. Any answer? See. You know, for when it is telling that divided D and C. Okay, let me see. We know this is axial point. We have discussed earlier. This is axial point, and we have named it as a axial point, and this was equatorial point. You remember this? No? And for axial point, we have also said that it is end-on position. Correct? Na? End-on position. And we know for this, theta is equal to 0 degree. And we have studied one formula also. E is equal to net electric field total is equal to P by 4 pi epsilon naught R cube under root 3 cos square theta plus 1 like this. And we have studied when we will put theta is equal to 0 degree here, we will get electric field like this. What will the electric field? P by 4 pi epsilon naught R cube, and cos 0 1, 3 plus 1 4, 4 means root 2. Now we can see here, we know that force is equal to QE. Now, first we know that electric field is dependent on R. How? R cube. That means we can say that E is inversely proportional to R cube, or E is equal to some constant into R cube. So it is telling that first, let us say first E1 is equal to K cube by R cube. R cube means first one, R cube. Now, second electric field, it is telling that distance is doubled. That means K by 2R cube. Like this, K by 2R whole cube. That means it will be K by it is 8r cube. That means it is E1 by 8. So force is QE. Force will also be double of 1 by 8 of original. Okay. Good. Let us move further. Good question. This is a very good question. And I think you should try. You should try this similar type of question we have done. You should try this question. Take a screenshot and try this question. Okay. Let us move further here. Try this question, all of you. 4 seconds. I give you 5 seconds. Try this question. All of you try this question. Okay. Yes, yeah. Getting. Good. Okay. It is telling that a hollow cylinder, it was asked in your exam, NEET only. It is telling that a hollow cylinder of Q charge is within it, Q charge is within it, and phi is the electric flux through the voltmeter associated with the curved surface. Phi is electric field associated with this curved surface. Okay. Now it is also telling that the flux through linked with surface A will be okay. It is telling how much flux will linked with it. We know that. Let us assume for this surface it is phi dash, and for this it will be phi dash. Okay. So total flux by Gauss law, we know that closed integration of flux is equal to Q by epsilon naught. So we can say that for here total flux will be phi for curved surface plus phi dash for this one and phi dash for this one. Okay. And it is Q by epsilon naught. Okay. Done. So from here we will get phi dash is equal to 1 by 2, and that will be the answer will be B. Okay. Time is getting short, so I have to move fastly. Okay, now you can solve it. This question, take a screenshot, try this. This will be the homework. You have to try this question. Okay. Take a screenshot of it and try this question. Okay. Good questions. Let me discuss this question. It was a good question. We are having lots of questions to discuss with you. Okay. But there's a time constant always present. So let me show. For this type of question, you know all. You can try this type of question. You know this, how to solve this type of question. Pith ball, hanging pith ball question. You know, we take tension here and we take suppose. Okay. This type of question, you know, like this, we solve like this. We take, suppose angle is, we take angle theta here. We say T cos theta here. We say T sin theta here. And we equate, we know between the pith ball, this will be the electric force Fe and gravitational force mg. Since it is an equilibrium, we can say that T sin theta is equal to Fe, left hand side is equal to right hand side, and T cos theta is equal to mg. When we'll divide this, we will get tan theta is equal to Fe by mg, like this. Similarly, we can write for this also. Okay. What we are getting? If this is theta, this will also be theta, alternate angle. This is given y. This will be, suppose it is r. It is given r. It will be r by 2. It will be how much? It will be r by 2. So tan theta is equal to, from here we can write like this, r by 2 by y from here. Okay. Similarly, you have to write for this also. You will get tan theta expression like this only, and you will equate like this. You will take theta angle here. You will take theta angle here. Let us suppose this angle is this is r dash. We will say this will be r dash by 2. You will say will be tan theta is equal to perpendicular r dash by 2 by y by 2. Okay. Now you equate this equation 1 and this equation 2, and after equating you will get the answer. Okay. Problem got it? How to solve? Okay, you will try this question, take the screenshot and proceed with this method. You will get the answer. Okay, any problem till now? Anyone, any problem in any question? Anyone, any problem in any question? Okay, okay, okay. Adiba, you also tell any question, any problem? Any question? Tomorrow we will be starting capacitor, and it will be very much important for your exam, and we will try to complete the chapter in a very fluent way, and it will be very much useful for exam also. And remember, the capacitor will be very much useful in understanding the concept of electric current also. So it will be a useful class, so don't miss it. Okay, okay, okay. Adiba, any problem? We are ending our session now. Any problem till now? Anyone, any problem? Or we shall end our session. Okay. Now we are ending our session. Okay. But your practicing of questions should go on. You should move with your question practice. And if you get any problem in practicing any of the question, or you face any problem, you can ask your question through any of the platform. You may be here, or you can talk with sir also.